Hey everyone, welcome to day 13 for Math 133. Today we're going to look at the Chapter 6 review worksheet. And Chapter 6 is the last chapter that is going to be on the midterm. So there are no lecture notes assigned. Um, we're going to hold off on doing lecture notes until the midterm. Um, so the plan for today is the Chapter 6 review. And then we're going to work a little more on the sample midterm. Okay. On Tuesday next week, there is no class. So try your best to come to the Monday and the Wednesday class because Elaine and Cindy will be able to work on the sample midterm with you. Okay. Um, but Tuesday next week, we would have covered the sample midterm. So it's here. If you need to click on it, it is due October 16th, which is next week on Thursday. So Thursday, October 16th, is the midterm. If you're taking it with me uh, in Zoom, we'll start at 9 a.m. Okay. If you're taking it at the testing center, then you don't need to come to class next week on Tuesday or Thursday. There's no discussion board for that week, and you don't need to worry about attendance points for next week. So Tuesday and Thursday, if you take it at the testing center, you don't have to come to Zoom. Uh, for the midterm, uh, on October 16th, if you are taking it with me, you'll submit your midterm in Canvas once you're done, just like submitting a worksheet. Okay. So you'll scan it in with your scanner on your phone. Okay. There's 9 pages, so try to make that a single document. I know some people have been submitting one page at a time. That's not going to be fun when you have 9 pages to do. So if you're not sure how to do that, Cindy can show you how to make it a single document. But if you have to submit it as 9 separate pages, that's fine too. Okay. Um, Next week on Thursday, we will assign the lecture notes for Chapter 7. So I'm just bringing that up now because, I won't see some of you guys if you're doing it at the testing center. Like I said, if you're doing it at the testing center, you don't need to come to the Zoom. But the lecture notes for 1.3, 1.4, 1.5, and then 7.1 and 7.3, those are going to be due on Tuesday, October 21st. Okay. Try to get those done before Monday, October 20th, because Cindy and Elaine will be using that material to go over some Chapter 7 stuff. Okay. And you are welcome to work ahead on the lecture notes. So if you have time, we don't have class next week on Tuesday. So if you have time, you can start working on those lecture notes now. Okay. It is easy to fall behind in this class. So if you work ahead on the lecture notes, that's one of the easiest ways to stay ahead of the game. Okay. If you're taking it at the testing center, you do not need to submit in Canvas. So if you're taking it at the testing center, you'll fill out your answers on the paper that they give you, and then I will get a copy of those papers from them. You don't need to worry about any of that. You just show up, answer the questions, and you're good to go. Okay. So even if it shows that, it's missing, if you did it at the testing center, you're good. Okay. Uh, Now, keep in mind the testing center, they keep track of who comes. There's a sign-in sheet as well as the tests. We had someone last year who tried to say, "Yeah, I took it at the testing center, and we did not have their test, and they did not sign in." So they have cameras there. It was clear that that person did not go to the testing center. Okay. Uh, So today is the chapter six. Oh, one last thing to mention about the midterm. So at the top of the midterm, there will be a link that you can click on if you are taking it with me in Zoom, and this will bring you here where you can click on these two things to get the data in StatCrunch as well as the Google Sheet for problem number 2. If you are at the testing center on your computer, you're going to want to make sure you carefully type this in https:// type that into the address bar so you can get to that website where then you'll be able to click on these two links to take you to StatCrunch and to take you to the Google Sheet. Okay. So go to the Google Sheet and fill that information in. Click on this, go to the StatCrunch, and you'll have all of the data already set up for you in StatCrunch. Okay. Okay. And I sent a message to Elaine with that link just to make sure it's working for her. So we're good. Um, okay. So today, the
I am
chapter 6
getting
review
through
worksheet.
it. Get into
What's
Remind. Sorry. Still getting into it. I had to get into Remind. For some reason, it wasn't letting me do it. So I'll let you know.
Yeah, no worries. So the chapter 6 review worksheet starts on page 408 in your course pack. So, by the way, this is so we're getting close to the midterm, right? The midterm is coming up. You can still turn in assignments even after the midterm that are late. You'll just lose a couple points for it being late. So do still turn things in. But since we're not having class on Tuesday, now and we don't have lecture notes, now is a good time to catch up on the stuff that you're behind on, especially since that material is going to be on the midterm. So it would really suck to go to the midterm and try to work on, the chapter 5 material if you haven't actually done the chapter 5 review, right? So, or you haven't done the chapter 6 review. So if you're behind on stuff, definitely catch up and turn stuff in, okay? So yeah, so you'll still get a grade if you turn it in as long as it's less than 3 weeks late. So if you turn something in that's 21 days late, at that point, it's going to be a 0. But you probably still want to do it, right? Because chapter 2 and chapter 3, like it's been a while since we've talked about that stuff, but it's still on the exam. So, all right. So on page 408, the chapter 6 review. Uh, so we're still talking about probability. Chapter 5 was all about probability. Now we're going to be talking about probability distributions. So the discrete probability distribution here shows the number of major cities per state in the US. So explain what must be true in order for this to be a valid probability model. So in order for it to be a probability model, uh, a valid probability model, all of these numbers, if you add them all up, you get 100%. So in math, this symbol means sum. This means probabilities, so probability of event X. If you sum up all of the probabilities, this one, all 7 of those, you get 1. If you want to write it in words, you can say they sum to 1. The probabilities sum up to 1. Also, in order for it to be a probability is a number from 0 to 1, right? It's a decimal or a fraction. So that means that every probability has to be between 0 and 1. So 0.34 is between 0 and 1. Okay. So we've seen before like 102%, that's bigger than 1. And so that one is not a valid probability. Okay. Um, all right. Down here, this is all fairly standard stuff. Question H is asking you to find the expected mean and the standard deviation. Okay. So to do that, we have 3 methods on how to find mean and standard deviation on page 254. And we finally get to talk about method 3. Okay. Page 254. So that's the yellow exam notes packet that you can take with you to the exam. And method 1 was if you have the raw data, you have a single column of data in a single column. Uh, Method 2 is if you have a frequency distribution. Method 3 is if you have a discrete probability distribution. Okay. And that's what we have in this case, right? The discrete probability distribution here. Okay. So uh, to do this, so you have to enter the x values or the midpoints in a column and the probabilities in another column. So you're going to have two columns of data. And here you're going to have to enter those into StatCrunch, and you'll do stat calculators custom. Okay. And then this is actually a weighted average. So it's not technically just for probability distributions. You could use this weighted average actually for other types of things. Actually, the frequency distribution one is a weighted average, just specific to a different type of question. So, okay, so for question 1, we need to put this information into StatCrunch. Now, if you click on the Chapter 6 review worksheet in Canvas and scroll down here, there aren't actually any links. So this data is not in StatCrunch yet. So you're going to need to put it in yourself. So we're going to go to statcrunch.com, okay, and then sign in. And then this big orange button in the middle, you're going to click on that, and that's going to bring you to a blank work page here, and you're going to have to go through and enter 0, 1, 2, 3, enter all these numbers. So these numbers here, these are my x-axis, okay? So the number of cities in each state, 0, 1, 2, 3, 4, 5, 6, and 7, okay? I know it says 7 plus, we'll just put in 7, okay? And then, so this is my number of cities. So, uh, apparently, there's a couple states with zero major cities. Maybe Montana. I don't know. I can only name one city in Montana. Wyoming. I think I know the capital of Wyoming. Uh, all right. Probabilities. I mean, you don't have to rename them, but basically, we're putting in two columns of data. The x-axis is our cities, and then the probability is here. Okay. So 0.24, 0.02, 0.04, 0.02. How many major cities does Michigan have? You got Detroit. I think Grand Rapids is the next largest. Is Lansing a major city? I don't know if it
Seems like
is.
it would be,
Lansing,
but
okay, so that's 3. Ann Arbor, that's 4.
yeah, oh, yeah, for sure.
So maybe Michigan's in this bucket here. Okay. Um, all right, so now that I've got my probabilities and my cities, okay, I've entered all those in. And on the test, we're not going to give you like a million rows to fill in, okay? But now that I have that, let's go back to our uh worksheet. So what do we click on? We click on Stat Calculators Custom. Okay, so let's do that. Hover over Stat Calculators Custom. Okay. It's going to ask which one is the values. That's the first column. That's the cities. Okay. Um, what we're trying to find is what's the average number of cities, average number of major cities in a state. Okay. Our weights are our probabilities, and then we hit compute. Okay. And it gives us a nice little bar graph here, but all I really care about is my mean and my standard deviation. So if I picked a random state, on average, one and a half, 1.58 major cities. Okay. So find the expected mean 1.58. And the standard deviation 1.86. Okay, great. Interpret the mean and the standard deviation in the context of the situation. So uh, a state has the average 1.58 major cities. This is our give or take script, right? Give or take. Then you write out the standard deviation, 1.86 cities. Okay. All right. So that's page 408. Let's go on to the next page. Page 409, we're going to do the same thing. We have a probability model here. Instead of a graph, they actually just have it as two columns for us already. But same thing, find the mean, the standard deviation. So this is again method 3. You're going to enter this column of data in StatCrunch, this other column of data in StatCrunch, and then you're going to do method 3
Oh,
on
good.
page 254, which is stat calculators custom. Okay. And the same interpretation. This is our give or take script. Okay. All right. All right. Baccarat is a casino card game where players bet on which hand will be higher. Um, Unlike many casino games, it's possible for there to be a tie. So you can bet, okay, I'm gonna be higher than the dealer, or you can bet on a tie, and you get more money if you bet on a tie. But if you're wrong, you lose money. Uh, so filling this out, so player higher is right here. Dealer higher is here. I don't know. Have any of you guys ever played Baccarat? I have not. And then we have our profits here. So that's what's going to go in here. So player higher, dealer higher, tie. -1, -1, 8. So if you play normal Baccarat, you're just bidding that you're going to be higher than the dealer. But you can bet on a tie where if you are higher, you lose $1. If the dealer's higher, you lose $1. And if you tie, you get $8. So you get a big payout, but it's harder to do. Now this is a probability distribution. So that means that these probabilities have to sum up to 1. Okay. So if we do 1 minus this one and 1 minus this one, so these sum up to 1. So we need to figure out what this number is based on we need to take 1 minus this one and then minus this, and that'll give us our answer there. Okay. Calculate the expected profit for a player making a tie bet. So to do that, you take each of the profits, which are here, and you times by the probability, and then you add them up. Okay. And actually, that is exactly what the uh, calculation for the mean is doing. It's doing a weighted average. A weighted average, you take this number times this one times this one times this one, and so on, and then you add them up. And that is how you calculate a weighted average. And that's exactly what we're going to do here. Okay. Um, so anyway, you take each of these numbers, this one times this one, this one times this one, this one times this one, and then add them up. Okay. Um, Part D, what is the house edge for a tie bet? You basically take the answer from part B as a percent. Okay. So, all right. I think that all looks good. So, okay, let's go on to the next page. You're going to roll three six-sided dice that have weights inside them. So they roll a six 75% of the time. So these are not fair dice. These are weighted dice. Okay. Why is it not appropriate to use a binomial distribution for the variable x in these three scenarios? So on page 256, an experiment is said to be a binomial experiment if the random probability is performed a fixed number of times, n. Each repetition of the experiment is called a trial. The trials are independent. Okay, that means they're not affected by outside things. For each trial, there are two outcomes: success or failure. Okay. The probability of a success is p, and then we also have q, which is 1 minus p. So that is the probability of failure. Okay. So in order for it to be a binomial experiment, these four things have to be uh, correct. It has to be fixed number of trials, independent, okay, and they have to be two disjoint outcomes. So suppose there's a way to use a magnet so that a person in the room can affect the dice rolls. You're going to toss the dice 10 times. Let X represent tossing a sum of 18. This is not a binomial distribution because one of these three things is happening. Not a fixed number of trials, not two disjoint outcomes, or the trials are not independent. Okay. Uh, it is a fixed number of trials. There's 10. We're trying 10 times. And there are two disjoint outcomes. You either succeed on rolling 18 or you fail on rolling 18. Okay. So the issue here is that these trials are not independent. They are affected by an outside source. So we said that these dice roll a 6 75% of the time. Well, that's not true if someone's using a magnet because they can use a magnet
Man,
to
I could have gave y'all
change
a little
that you
bit more
roll
tea.
6 more
We
often or
talk about
less
it
often.
about the sober. Ain't y'all look at Derrick Rose? Derrick Rose, like, he escaped.
Okay. Part B. You are going to toss the dice 22 times. Let X represent the sum of the three dice. So this one is also not a binomial distribution. Uh, so either it's not a fixed number of trials, or we don't have two disjoint outcomes, or the trials are not independent. What do you guys think for this one? What's the problem on this one?
And not two Julian Coons.
Say that again? Sorry, I didn't hear you. Do we have a fixed number of trials? How many times are we going to roll the dice? We're going to roll the dice 22 times. So that's good. Okay. Do we have two different outcomes? So X represents the sum of the three dice. Well, the sum could be 3, it could be 18, it could be 10, it could be 11. So the problem here is you don't have a defined success or failure. We're going to toss the dice 22 times, but I don't know what I'm trying to get. Am I trying to get 18? Am I trying to get something lower? Okay. Part C, you can probably guess the answer to this one. You want to get a sum of 18. So in this case, we have a success or failure defined. Let X represent the number of tosses it takes to get 18. The problem here is we don't know how many times we're going to roll the dice. You might roll the dice one time and you get 18 on the first roll, or you might roll the dice 100 times, and so it's not a fixed number of trials. Might take a long time to get 18, depending on how often it takes, how the dice land. So, okay. So page 256 is all about chapter 6 stuff. So you can find information about that on question number 5 on page 256. Also question number 6. Question number 6, the following are all graphs of a binomial distribution. N is the number of trials, so 260. Label each graph with its probability of success. So is P 0.1, 0.5, or 0.9? So on page 256, if you have a binomial distribution, then the mean is the number of times that you're going to roll the dice, the number of trials, times the probability of success. That'll give you the average number of successes, okay? So in this case, we would just take our n times p, and that'll tell you what the mean is, right? The mean is the middle number. The standard deviation of a binomial distribution is sigma, and that's the square root of n times p times q. Okay. So there's that. So you'll need that for number 6. All right. Last page, and then we'll dive in, is number 7. So the CDC's found that 12.3% of US teens have been bullied online. You're going to randomly select 180 US teens. We can presume this qualifies as a binomial experiment. So again, if it's a binomial experiment, then the mean is n times p. And the standard deviation is the square root of n times p times q. Okay. Okay, sounds good. So I'm going to pause the recording there. Let's jump back to the start of this worksheet on page 408.